There is activity in this supervolcano which erupts roughly every 600 million years. When it blows, it could destroy the United States as we know it.
Hold your breath and brace yourself for the shocking revelation that we're about to share. Yellowstone National Park, a pristine wonderland known for its breathtaking landscapes and geothermal marvels, harbors a shadowy secret deep within its core. It's a mystery that has baffled scientists and seismologists for years, keeping them on high alert, waiting for that fateful moment. And now, we stand at the cliff of a potentially disastrous event. But what if I told you that the latest findings have triggered alarm bells across the scientific community? Brace yourself, for the Yellowstone volcano has finally unleashed another perplexing sign, one that could signify something far more ominous. Recent reports have caused shockwaves throughout the research world, as the Yellowstone System Alert detected a strange surge in dome shaft uplift, a staggering 250% increase to be exact. As we explore this captivating and nerve-wracking topic, the question that bites at our very core is, could this astronomical surge in dome shaft uplift be an ominous indication of an impending Yellowstone eruption? Join us on this exploratory journey where we solve the mysteries behind the sudden 250% increase in the dome shaft uplift, diving headfirst into the heart of this geological marvel. Get ready for some astonishing discoveries, fascinating scientific discoveries, and the hidden truth that hides beneath the surface. Are you ready to face the unnerving possibilities that lie within Yellowstone National Park? The unfolding events surrounding the sudden dome shaft uplift read like a thrilling movie script. It all began when the Norris Geyser Basin temperature logger system was repaired, allowing the team to gather valuable data on Steamboat Geyser's activity. To their surprise, they discovered two eruptions that went unnoticed. The most recent eruption occurred on May 7th, making it the fourth eruption of the year. As time went on, town officials noticed a significant rise in temperatures amongst specific thermal features on Geyser Hill, near the iconic Old Faithful. Adding to the intrigue, a new thermal feature emerged, unleashing a powerful mix of mud and scalding water onto the nearby boardwalk. For the safety of visitors, authorities had to close off that section of the trail. Interestingly, this activity occurred in the same area where a similar disturbance took place on September 28th. During that event, the eruption of the Year Spring revealed decades' worth of discarded items, including coins, hats, a cinder block, and even a pacifier. While such occurrences are not uncommon in Yellowstone National Park, they serve as a vivid reminder of the ever-changing and dynamic nature of its thermal areas. However, they can also signify an impending disastrous event, a fact acknowledged by even the U.S. government. Another sign recently emerged in the form of seismic activity. The University of Utah seismograph stations responsible for monitoring the Yellowstone seismic network detected a total of 148 earthquakes in the region. Among them, the most significant event was a minor earthquake measuring 2.8 magnitudes, which occurred on May 25th at 11:40 p.m. MDT, about 5 miles north-northwest of Norris Geyser Basin within Yellowstone National Park. These earthquakes formed 4 distinct swarms. The first swarm, spanning from May 4th to May 30th, comprised 34 earthquakes, located approximately 5 miles north-northwest of Norris Geyser Basin. Within this swarm, the largest earthquake measured 2.8 magnitudes, making it the most significant quake recorded in May. The second swarm, occurring from May 11th to May 26th, consisted of 28 earthquakes, around 9 miles northeast of West Yellowstone, Montana. The largest earthquake within this swarm had a magnitude of 2.6. The third swarm, with 19 earthquakes, struck approximately 4 miles north and northwest of West Thumb in Yellowstone National Park, with the most notable event measuring 2.3 magnitudes. On May 29th, the fourth swarm occurred in the same area as the previous West Thumb swarm, encompassing 12 earthquakes, and the largest earthquake in this sequence had a magnitude of 2.1. It's worth noting that earthquake sequences like these are common, and they contribute to about 50% of the seismic activity in the Yellowstone region. These recent developments have set the stage for a potentially destructive event, sending ripples of concern throughout the scientific community. Will the sudden dome shaft uplift and seismic activity pave the way for a devastating eruption? In May, something extraordinary happened within the vast expanse of the Yellowstone caldera. The ground deformation, which had been steadily sinking since 2015, suddenly showed a change of pace. Instead of continuing its descent, the ground exhibited a slight uplift. Now, this might not seem like a big deal at first, but let me tell you, it's part of a fascinating phenomenon that occurs every summer. You see, these snow-capped mountains melt, and as they do, and the water seeps into the earth, it's like pouring water onto a sponge. The ground expands, causing this temporary pause in subsidence and transitioning into a minor uplift. It's a natural occurrence, almost like the breath of Yellowstone itself. But let's talk about why this matters. Yellowstone National Park, with its majestic beauty and extraordinary thermal features, holds immense significance. And the Yellowstone Volcano Observatory is a crucial entity that tirelessly monitors volcanic and seismic activity within the park and its surroundings. They work together to ensure our safety and uncover the mysteries of this geological wonder. The Yellowstone Volcano Observatory consists of several agencies, including the United States Geological Survey, or USGS, Yellowstone National Park, and various universities and geological surveys. Their collaborative efforts help in the scientific research effort and keeping a watchful eye on the ever-changing landscape of Yellowstone. Recent discoveries revealed a warning site dedicated to the sudden uplift phenomenon in Yellowstone. This vigilant monitoring plays a vital role in detecting any potential signs of an imminent eruption. And recent observations have given us a glimpse of new ground cracks and intriguing alterations beneath the surface, captured through satellite imagery. You see, just like any other volcano, Yellowstone exhibits its own warning signs, signaling its preparation for an eruption. Imagine a mountain bulging, growing at a rate of 5 feet a day, much like Mount St. Helens did. In the case of Yellowstone, this uplift would encompass the entire caldera, an area larger than Houston and Dallas combined, raising it to more than 10 feet above ground level. These warning signs would prompt an evacuation plan of a strange magnitude, spanning weeks or even months before the eruption. The immediate vicinity of 60 miles around the volcano would be considered a just hazard zone, while officials would extend their alerts up to 200 miles from the epicenter, preparing the surrounding region for the possibility of a violent eruption. As geologists closely monitor the area, they rely on seismic activity to guide them. Professor Bill McGuire, a renowned volcanologist, highlights the importance of earthquake swarms as an indication of fresh magma entering the volcanic system, fracturing the rocks below. These earthquakes produce distinct waveforms on seismographs, with a sharp rise and a quick fade. They serve as an early warning sign, impacting both the hazard zone and the surrounding areas. But as the eruption draws nearer, seismic activity takes a dramatic shift. The earthquakes transition into a continuous vibration, signifying the magma's movement through the cracks and conduits deep beneath the surface. It's like the rumble of an immense force awakening, a vibration that sets off alarms in the scientific community. And just before the eruption, there is a final warning sign, a harmonic tremor. Picture the vibrations produced by a grand organ pipe reverberating through the earth. It's a distinctive seismic signal that foretells an imminent volcanic event. Over the years, scientists and organizations have tirelessly searched for ways to prevent a potential eruption at Yellowstone. One intriguing idea proposed by NASA involved increasing the volume of water within the volcano, aiming to extract heat and reduce the risk of dangerous pressure buildup. However, after careful evaluation, this approach was deemed too challenging and too risky to implement. The United States Geological Survey now dismisses any speculative theories about Yellowstone's eruption patterns, as super eruptions don't really follow a regular interval. Drawing meaningful conclusions from such speculation is therefore futile. Even if the Yellowstone were to erupt again, there is no guarantee that it would be a large-scale eruption. The most recent lava flow occurred about 70,000 years ago, with a more significant eruption taking place about 174,000 years ago. Interestingly, similar abrupt transformations have occurred in the past. Moving to the Norris Geyser Basin, located northwest of the caldera, we encounter over 500 dynamic hydrothermal features. These geysers and pools undergo daily changes, but on a larger scale, something intriguing has been happening for over 2 decades. An area larger than Chicago, centered near the basin, has experienced irregular fluctuations, inflating and deflating by several inches. Understanding the causes of such movements in a highly active volcanic region like Yellowstone presents a challenge. However, a recent study published in the Journal of Geophysical Research, Solid Earth, sheds light on the breath-like behavior of this specific land area. Researchers analyzed extensive satellite-based radar GPS data spanning several decades to construct models of the subsurface activity beneath the Norris Geyser Basin. In the late 1990s, a magma body intruded beneath Norris, releasing trapped fluids that traveled through the rocks above, causing pressure to rise and the ground to lift. When the fluids found alternative pathways to escape, the ground deflated. Magma-derived fluids may be situated relatively close to the surface, around a mile below ground level. It's important to note, however, that this new research doesn't indicate an increased likelihood of a supervolcano eruption from the Yellowstone caldera, which last occurred around 640,000 years ago. Instead, these geological movements offer insights into the height and the eruption frequency of the Steamboat Geyser, the tallest active geyser globally, which has been erupting at an unprecedented rate since March 2018. Researchers also speculate that the changes beneath Norris may slightly elevate the probability of hydrothermal explosions in the basin. Yellowstone's geology remains complex and mysterious, posing significant challenges to exploration. Nevertheless, scientists agree that the introduction of magma and the subsequent release of fluids may explain the dynamic fluctuations in the ground. Michael Poland, a scientist at the U.S. Geological Survey's Yellowstone Volcano Observatory, not involved in the recent study, remarks, "We're only scratching the surface of comprehending the true extent of Norris Geyser Basin's dynamism." The Norris Geyser Basin, the oldest thermal area in Yellowstone National Park, holds secrets dating back 115,000 years. Buried beneath its surface, temperatures soar to a scorching 459 degrees Fahrenheit. Deep within this fiery domain resides the captivating Steamboat Geyser, known for its unpredictability and spectacular eruptions. Once dormant for years, this towering geyser has recently unleashed a series of astonishing displays, erupting as frequently as once a week since March 2018. In 2019, it shattered records with a staggering 48 eruptions. Helen Robinson, a geothermal expert, describes the geyser's behavior as absolutely crazy, leaving scientists both fascinated and puzzled. But it's not just the geyser's spectacular eruptions that have researchers intrigued. The land surrounding Norris Geyser Basin has experienced dramatic shifts. Between 1996 and 2004, it rose by 4.7 inches, only to sink by 2.8 inches from 2005 to 13. However, a remarkable event unfolded when between late 2013 and early 2014, the region surged upward at an unprecedented rate of 5.9 inches per year. This uplift abruptly ended with a magnitude of 4.9 earthquake in March 2014. Since then, the area has displayed a fluctuating pattern of sinking and rising, leaving Norris Geyser Basin currently resting approximately 5 inches higher than in 2000. To solve these mysteries, scientists analyzed radar and GPS data from satellites. Their findings suggest that magma ascended about 9 miles below the surface between 1996 and 2001, causing the initial uplift. As the magma cooled, trapped fluids were released, reducing the internal pressure and resulting in ground subsidence from 2005 to 2013. Since then, intermittent accumulation of fluids beneath the rock layers has led to the sporadic episodes of ground uplift here. Robinson speculates that comprehending the interplay between magnetism and hydrothermal activity is still a puzzle. He suggests that the accumulation of fluids, possibly influenced by recent snowfall, could be likened to the landscape taking in and releasing breaths. While the potential for hydrothermal explosion exists, predicting such events remains nearly impossible. Nevertheless, major explosions at Norris Geyser Basin are infrequent, offering a glimmer of reassurance amidst the uncertainty. But what lies beneath the surface of Yellowstone National Park, you ask? It's a complex network of rocky plumbing systems, constantly in flux with the potential for eruptions. Despite this uncertainty, the team cautions against closing off the region to visitors, as the speculative nature of additional explosions makes it difficult to predict. The team's also focusing on the connection between the buildup of magmatic fluids and the unusually high number of eruptions occurring at Steamboat Geyser. Similar periods of increased activity were observed in the 1960s, when in the early 1980s as well, possibly linked to the cyclic breathing patterns of the basin. However, the connection between Steamboat's hyperactivity and the intrusion of magma is still largely circumstantial. Further investigation is needed, including analyzing the chemical composition of surface bubbling fluids to determine their magmatic origin. The ability of researchers to provide credible interpretations for these noteworthy transformations is truly impressive. Through years of gathering data and advancements in scientific knowledge, what once seemed unattainable has now become attainable. Their unwavering commitment drives them to meticulously explore the root causes behind these phenomena. The study shed light on the two notable instances of uplift that took place in 2013 and 2014, and 2016, of course, potentially linked to an underground movement of magma that occurred 20 years prior. Spanning an impressive area of 30 by 45 miles, the Yellowstone caldera comprises 3 calderas that have 2 resurgent domes, surpassing the size of certain countries. Detecting significant geographic changes over such vast areas presents a challenge. Luckily, the vigilant Yellowstone Volcano Observatory continuously monitors the volcano and its surroundings, observing any deviations from normal background movement. Their recent observations of uplift and subsidence form the foundation of the U.S. Geological Survey's article. As we explore the mysteries hidden beneath Yellowstone's surface, we come to understand the delicate balance between volcanic forces and the marvelous landscapes that we behold. The ongoing efforts to decipher these phenomena serve as a testament to the scientific community's dedication and the invaluable knowledge gained from years of observation. In 2013, something extraordinary began happening in a specific part of Yellowstone. The ground beneath our feet began to rise at an astonishing rate, reaching a height of over 5.9 inches in just 2 years. Now, you might be thinking, what's the big deal? But let me tell you, that uplift is unlike anything ever witnessed in Yellowstone before. That's a record breaker. But here's the thing. The unusual movement of Earth crust didn't just pop up out of nowhere. In fact, scientists first noticed this peculiar pattern way back in the 1970s. They took a closer look at their data, and they were stunned to find that Yellowstone had undergone a staggering 28 inches of uplift over the last 5 decades. Imagine that. The ground beneath us silently shifted and changing over all those years. Now, let's dive into the heart of the matter. The heart of the volcano, if you will. The experts have a theory about what's causing this mesmerizing uplift and its accompanying subsidence. They believe that it all traces back to underground magma intrusion that occurred between 1996 and 2001. You see, there's an excess of magma lurking beneath Yellowstone's surface, and it's been stirring up some trouble. In 2013, things really started to heat up. The excess magma caused the ground to swell like a giant balloon ready to burst. But then, a jolt from a 4.9 magnitude earthquake temporarily halted that uplift. Between 2016 and 2018, the uplift resumed, as if it couldn't resist showing off its power once again. Now, let me tell you a fascinating story about Yellowstone National Park. You see, the uplift of Yellowstone has a profound impact on its hydrological features, like the famous geysers and hot springs that makes the park so unique. One particular geyser, Steamboat Geyser, holds the record for the highest number of eruptions in the world. In 2018 alone, it erupted 32 times. And the following year, it astonished everybody with a staggering 48 eruptions. But what could be causing this surge in hydrothermal events? According to the Yellowstone Caldera Chronicles, a weekly publication by the Yellowstone Volcano Observatory, the increased geyser activity is closely linked to the presence of shallow magma underground. Interestingly, Steamboat Geyser went through a similar phase of heightened eruptions back in the 1960s and early 1980s. This reveals a remarkable pattern, showing that increased geyser activity doesn't always indicate an imminent volcanic eruption at Yellowstone. So, there is no need to panic or feel anxious about it. Nonetheless, the increased geyser activity in Yellowstone is truly captivating. It offers scientists and researchers invaluable insights into the dynamic nature of the park's geothermal features. They tirelessly monitor and study these changes to gain a deeper understanding of the underlying geological processes and their implications for the future. It's a continuous exploration that keeps us all spellbound. But let us not jump to conclusions just yet. While the uplift, subsidence, and heightened geyser activity are undeniably intriguing, they don't necessarily point towards an immediate volcanic eruption. Yellowstone remains a captivating wonder, a natural masterpiece that requires ongoing scientific investigation and the public's keen interest. Now, here's a thought that will probably pique your curiosity. What are your thoughts on the sudden increase in dome shaft uplift observed by the Yellowstone Volcano Observatory? Are we on the brink of a volcanic eruption, or is there more to the story? Let us know in the comment section down below. Okay, bye.